Welcome to Center of Math's Advanced Knowledge Problem of the Week. For this week's problem, we want to prove there are two opposite points on Earth's surface that are at the same temperature. And for this, we're assuming Earth is just a perfect sphere and temperature is a continuous function on Earth's sphere. So to do this, we're going to make use of the intermediate value theorem, and we're going to construct a function from reals to reals that where it takes a zero, we'll be able to conclude that we have such a pair of points. So Earth is some kind of sphere. We say we have points W in three-dimensional space on the sphere. We also have points minus W, which is just on the opposite end. So if the origin is at 0, 0, the sphere is centered at the origin. It's minus 1 times a vector. So we have some continuous function t of W from R3 to R. So we have some temperature t of W. There's some temperature all around the sphere. And we're going to define a function from R cubed to R, t of W minus t of minus W. And so, so now we have a new function. And so if this function is ever 0, that's exactly what we want. Then we have t of W equals t of minus W, and we have two opposite points with the same temperature. So to prove that this must happen, we're going to say, take some point W, take some point minus W, carve out some path on the sphere. It can just be a great circle going from W to minus W. So this can be parameterized in one variable. And so we define some path f, that's a function of t. T is one, just a real number, so f defined on the closed interval 0, 1 gives us this path in R cubed, and where we say f of 0 equals W, f of 1 equals minus W. And so g of f of t is in fact a function from the closed interval 0, 1 to R, where g of f of 0 is g of W, g of f of 1 is just g of minus W. And yeah, one important thing to note is we have g of f of 0, which is g of W, and g of W equals minus g of minus W, because if we plug in minus W here, it becomes t of minus W minus t of W, which is just minus g of W. So we have g of f of 0 equals minus g of f of 1. So if g of f of 0 equals g of f of 1 equals 0, then we're done, because we have a point where t of W equals minus t of minus W. If that's not true, g of f of 0 does not equal 0, then it's positive or negative, in which case g of f of 1 will be the opposite sign. So if it's positive, that endpoint will be minus. If it's minus, endpoint will be plus. And so this tells us we have a function, a continuous function defined on 0, 1 going to R, that if these two endpoints are not 0, it has a plus, a point where it's positive, a point where it's minus. And so by the intermediate value theorem, there must be some g of f of a where, So yeah, if g of f of 0 does not equal 0, then it's either plus going to minus or minus going to plus, in which case there exists some u such that g of f of u equals 0 by the intermediate value theorem, and thus f of u will be our desired point, giving us two opposite points with the same temperature. Thanks for watching. If you like this video, please check out centermath.org and follow us on Facebook and Twitter. Thank you.